In this activity, we're going to use math to explore the political concept of gerrymandering. For the warm-up question, you're going to want two different kinds of objects. I'll be using red and blue counters, but anything around the house will do. For instance, pennies and quarters would be great for your different voters. For the main activity, you're going to want maps. You'll be able to download these at mathcircles.org, and we have a full set of challenge maps. I laminated mine so I could use them again, but if you have clear plastic binder sleeves to put them in, that would work fantastic with expo markers. Let's start by answering the question, what is gerrymandering? It's the process of manipulating districts or boundaries in such a way that unfairly favors one political party over another. Let's use a warm-up question to show an example of this. We have an election of 25 voters, choosing between two different parties, red and blue. We have 15 voters in favor of the red party and 10 in favor of the blue party. If this were what we call a general election, where every voter gets one vote and whichever party receives the most votes wins, red would win handedly. But that's not how a lot of elections work. They go into districts, where every district gets a certain amount of votes, and depending on who wins the most districts, wins the election. In this example, we have our voters in 5 districts, each getting 1 vote. If we look at our example then, we see that 4 of our districts have a majority of red voters, meaning that they vote for the red party, while 1 district votes for the blue party. So red would win this election 4-1. But let's maybe move things around a little bit. I'm going to swap out one of my voters right here with its neighbor in another district. Now, when I'm looking at this, I see that red's only winning 3 of the districts, while blue has 2 districts where it's the majority, meaning it gets 2 votes. This gets us to our first question. Is it possible to arrange our voters in such a way that blue wins at least 3 of the districts and therefore the full election? Be creative in how you move around your voters. If you're able to do that, let's make the question harder. I'm actually going to flip one of my voters. So now I have 16 red voters and only 9 blue voters. Is it possible to move your voters around so blue wins the election? If so, what is the fewest number of voters blue would need to win this election of 25 people? Now, we're going to add a geographic component to these problems. Like before, you want to group 25 voters into 5 different districts, each with 5 voters. But now, our voters have to be adjacent to each other, meaning that our voters are going to be represented by squares that share edges with other squares. Let me do an example and make some districts. I'm going to start by grabbing these 5 voters up here. All of my squares are connected to each other by sharing edges. And if I look at this district, I see that I have 3 in favor of the red party and 2 in favor of the blue party. So red wins that district. Let me see if I can make one that's in favor of the blue party. Well, I'll grab these 5 voters down here. Our goal is to see if it's possible to district our map in such a way that blue is able to win at least 3 of the districts. Every voter must be placed into a district, and all of your districts must be equally sized. If you're able to solve this problem, we have 3 more maps just like it, and we have 1 extra challenge map with data taken from the website 538.org based off voter preferences on Colorado. To find this activity, all of the materials, and a lot more, check out mathcircles.org. We have a ton of fun problems and we're always adding more.